All right. Good morning, everybody. Um, I I just want to go over this because I think this is really important, and I am concerned that people. This is one of those where you got to take it seriously, and I want to make sure that while I am not necessarily somebody who is super trained in this, I have studied this enough to be able to point out the things that say, "Hey, this is going to be bad," and I want to make sure that I say something about it because the more people that will say it to you, the more people you're likely to hear this from. So, a couple things. This is a rap sounding. It is a modeled sounding based on everything that we've seen before. These are the things that make forecasts. Okay, this is a rap sounding, and that's what they do. So, a couple things to point out. So, it is April 28th at 2200 UTC. This is right at the Twin Cities. 2200 UTC is 1700, which is, of course, 5 p.m. So, those are the important pieces for time. Um, and if you look at the thing, you'll see that yes, this is actually for the Twin Cities. If you look at the what is that coordinates, but you don't have to do that. I want to circle down here the threat, which is a potential hazard. It's PDS tornado. And if I remember correctly, PDS is particularly dangerous situation. So, I know you're hearing a lot about the things that might happen on Monday. I want you to know that this is absolutely something that is problematic and that you need to be aware of. You just need to keep your ears open, all of those things. So, a couple things that on this table of information that you might think, okay, Matt, what does it matter? So, the first thing to note is the what's going on. So, we're going to look at three things in particular. We're going to look at this here, and specifically this area right here is important. And then this area right here is important. Those two will give us a lot of information. So, what are we looking at? Well, first off, this red line here, right here, if I can get my thing to work, is temperature. And this y-axis here is altitude. Okay, so this is temperature with altitude. And then this green area here is the dew point. And of course, that also works with the altitude. So this is dew point with altitude. Okay. You'll notice down here at the bottom that they're very close together. This means it's not going to take a lot for storms to initiate. If you see a dew point and temperature that are way far apart, you're like, okay, nothing's going to happen. Like, there's not enough moisture in the air for a storm to happen. In this case, there is enough moisture in the air for storms to happen, and therefore, we know that it's a possibility. So that's point one. Second, and I circled it up here, but I want to make note of it. This area right here, between that blue line and you know what? You're gonna catch my ignorance here. I don't know what that blue line is. I believe it's expected temperature based on what we think the atmosphere should have. But that yellow area there, that little gap, I'm gonna unfill it so you guys can see it a little better. But that yellow area there, that gap between those two lines, the red line and the blue line, that is our instability. Okay. So that instability, that is the area where the storm can increase the temperature because there is convective available potential energy. You may have heard of CAPE before. So that's the CAPE right there. And we can see that those CAPE values right here. CAPE is listed in joules per, oh man, I want to say it's kilogram cube, but I could be wrong. And there's nowhere for me to see it, is it? I don't think it shows it on the, nope. I don't know where it's at. So, anyways, but that gap right there is pretty big, and you're seeing down here values that indicate um, quite a bit of cape. So these values here, I don't remember what each one of them is. Frankly, it doesn't matter because each one of those is over 1500, which is what you need usually to have significant um, what's the word I'm looking for? Supercells. There we go. Um, and anything over that 20 or 2000 is like okay, maybe there's a problem here. So that's definitely something we're looking at. And then there's also the nope, that's not there. I'm trying to figure out where some of these. I don't look at these often. Okay, I know what they look like and I know what to do with them, but that's that's what we're looking at there. So a lot of instability, right, in that gap. We can see that down here at the bottom, the dew point and the temperature are close together, which means that storms can initiate. If there were a huge gap between those two, then we would say probably not, but it does look like that's the thing. And maybe you've heard about the cap, and I think this little itty bitty part right here, that looks like it is a cap that might be breaking. Um, and so this is a loaded gun scenario with a lot of instability. The environment is ripe for storms to form, um, and so that's what we're looking at. So that's all in that area, right? If we move over, though, this is where the concern is a little greater, if we're being honest. So this is a photograph, and a photograph gives us wind direction with height. So the axis, um, I don't even know how to describe it, like, because my brain hurts every time. But I think a way to look at it is these here are the wind directions with height as well. You can see that, right? And so what you see is at the surface, winds are going north, and then when we get higher, they're going northeast, right? So you can see that here at the beginning, the winds are going north, and as we go higher, they're going northeast, right? So you can see that as the winds, and that gives some of that good old twist. And that twist is what tornadoes need to form. Um, Now, we're not like 100% sure how all this works, okay? Just be honest. But that leads us down here to these storm relative helicity values, SRH, and it's in meters squared per second squared. And that SRH, those are really high SRH values, like terrifyingly high. Tornadoes can form consistently from what I've seen. Now, granted, I'm, again, not a trained meteorologist, but somebody who has loved this stuff for a couple years and watches a lot of informative videos on this. And SRH of 150 can form tornadoes. It's not like a particularly good environment for it, but they can. Um, so what you're seeing here specifically is a very high storm relative helicity with pretty high Cape values in a very soft cap environment, which is kind of that loaded gun scenario. So when we talk about this particularly dangerous tornado situation, we're not kidding. This is an this is an environment where tornadoes can absolutely happen. They can be big, they can be long track. They're going to be it's entirely possible and probable that we see something like this happen, okay? You just need to be aware. I'm not saying that one is going to hit your house, okay? That's not what we're saying. But given the information we see, this is definitely something that you want to be aware of and something you want to um, just know is going to happen. So keep that in mind as you go forward. And this is again for Monday. This sounding specifically was for 5 o'clock. I don't know what time. Talk to listen to real meteorologists for timing. But what I am telling you is as someone who has seen a lot of these soundings and watched a ton of content and really devoured how to do this, this is a scenario which can lead to bad things. So just be aware. Don't be afraid, but be aware.